This is Ken and the guys, and Mr. Rosever, and we're gonna continue with this discussion of remainder theorem. There's two kinds of problems you can get. The first one is of this type, and based on what I just told you in the previous video, if you actually watch that thing, you're gonna need to watch it all. Oh my gosh, hold on. Oh, okay. I thought the microphone wasn't in the right spot. But we learned in the previous video that any polynomial can be written as a quotient times a divisor plus a remainder. And these quotients, divisors, and remainders can all be functions of x, which is why I wrote them as q of x, d of x, and r of x. Now in this case, they're telling us dividing the polynomial p of x by x minus 4. So x minus 4, if we're dividing by x minus 4, which one of these is x minus 4? Repeat the question. All right, if we're dividing the polynomial p of x by x minus 4, which of these functions down here, q of x, d of x, or r of x, is x minus 4? Yes, it is d of x. Why is it d of x? Because it's the divisor. Very good. Okay. And r of x, what's r of x? Continue reading, and it tells us we get a quotient of q of x. So they don't tell us what the quotient actually is, other than that is some function of x, and a remainder of 9. So the remainder is not a function of x, it's a constant. So it's 9. Um, if q of negative 4 equals negative 2, find p of 4 and p of negative 4. So they tell us q of negative 4 equals negative 2, and they want us to find p of 4 and p of negative 4. So let's finish writing the equation. P of x, which we don't know, is equal to q of x times x minus 4 plus 9. If I want to find p of 4, then I am necessarily going to have to put in a 4 and hope that something works out where even though there's so much I don't know, I will know enough to be able to figure this thing out. Okay. And what do I see? I actually see a 4 minus 4 here, which makes me happy because 4 minus 4 is 0, and q of 4, no matter what it is, times 0 is 0. That was very musical. Plus 9 is 9. So p of 4 is 9. And we know that just based on that limited information we did have. Now we can also find or p of negative 4, but the only reason we can do that is because they were kind enough to provide us with some information up top. P of negative 4, the second part of the question, I find by evaluating at negative 4 the polynomial. So I plug in negative 4 everywhere I see an x. I get q of negative 4. Now normally I wouldn't know that because I don't have the quotient function, but I do in this case because it's provided. Actually, let me do this. Oh, it's provided. It's right there. Q of negative 4 equals negative 2. So we're going to use that information right down here. We're going to do a substitution. So that's a negative 2. This is negative 4 minus 4, negative 8, plus 9. Order of operations, we do these guys first. 16 plus 9, 25. So our two answers were 9 and 25. So 4 comma 9 would be a point on that polynomial, not that they ask you for that, and negative 4 comma 25 would be a point on that polynomial, okay, on its graph. All right, we have one more. And let's see if we can bring up one of these real quick. I'm going to pause. All right, we're back. You don't know it, but that 1 millisecond there took a few minutes. This is the other kind of problem that we have when we're doing ALEKS and they ask us to, do the remainder theorem concept. They can give it to us like this. It says consider the polynomial p of x equals k of x cubed minus 4x squared plus 3x plus 4. And they want us to find the value of k such that the remainder is 1 when p of x is divided by x plus 1. Well, we know from the theorem we just had that what happens when we divide by a divisor? We always get a quotient and a remainder, right? So anytime we divide p of x by some divisor, we can write it as p of x equals the divisor times the quotient plus the remainder. And let me just show you this real quick. Since the divisor is x plus 1 and the remainder is 1, doesn't that mean that p of negative 1, oops, let me put an x there. Doesn't that mean that p of negative 1 equals negative 1 plus 1 times q of negative 1 plus 1, and this is 0? Doesn't that mean p of negative 1 is 1? Okay, and the reason for that is, where did I get negative 1? It's the 0 of the divisor. So looking up here, if I have it in this funky form here, p of negative 1, I know equals 1 because that is the remainder when we divide by that. Remember that when we plug in the 0 of the divisor, the remainder is p of that 0. So the 0 of the divisor is negative 1. If I plug it in, you can see I got a 1 here. Okay, so p of negative 1 is going to come out to 1. But look at p of negative 1. Isn't that going to be k times negative 1 cubed minus 4 times negative 1 squared plus 3 times negative 1 plus 4? Isn't that p of negative 1 by putting in negative 1 everywhere for x? And isn't that equal to 1 because of this theorem up here? So if that's equal to 1, now I just go, that is negative k. Let's see, that's a positive times a negative is minus 4, minus 3 plus 4 equals 1. And I just combine like terms and solve. Those are like terms and opposites, so they cancel. If I take the 3 and move it to the other side, I add it. And so I get negative k equals 4, which means k equals negative 4. The answer is k equals negative 4. How can we check it? It's always good to be able to do a check. How did they say we got, oh, whoops. How did they say that we came up with a remainder of 1? We divided by x plus 1. So what I'm going to do now is I'm going to divide by x plus 1 using synthetic division. And when I do, I put a negative 1 there, right? And let me just check my time. Okay. When I put negative 1 there, I put all the coefficients. So they were, I'm saying k is negative 4. But I'm gonna put k in synthetic division just for a second to show you something crazy. Aren't the coefficients here k, negative 4, 3, and 4? Okay, so watch this. This is going to be good. I'm going to put in k, negative 4, 3, and 4. And watch what happens when I do synthetic division on this. Don't I first drop down the k? What's k times negative 1? Negative k. What's negative 4 minus k? Isn't it just negative 4 minus k? They're not like terms you can't do anything. All right, what's negative 4 minus k times negative 1? Very good. 4 plus k plus 3 is 7 plus k times negative 1 is, all right, and when I add these up, what is 4 minus 7 minus k? Negative 3 minus k. But what did they tell me the remainder would be when I divided? Well, they told me 1. So if this is my remainder and they're telling me it equals 1, I set it equal to 1. Add 3 to both sides. Don't I get negative k equals 4, which is the same thing as I got here? K equals negative 4. So that's another way of doing it. You can do synthetic division with the k in there and then take your remainder and set it equal to the remainder they told you you should get, and then you can solve for k. That's the harder of the two problems, okay? But now you know how to do it if you watch the video again, right? It might take you another couple times. Okay, there you go. That's it for now. Adios. Bye.